Welcome. Last time we just looked at the definition of improper integrals. Now we are going to look at some examples of calculating them. In order to do this, we have to recall some of the basic facts about finding limits at infinity and negative infinity. Remember these limits from chapter 10 and also recall how we found limits of algebraic expressions. Most of these limits can be obtained by using these two, and there are a few problems where you have limits of exponential functions. Make sure you have these limits handy because this is what we are going to need to do some of the problems involving improper integrals. The first example is the integral from 1 to infinity of dx over x squared. I will generally break up evaluation of improper integrals into 3 steps. This is because of the way we defined improper integrals where one or the other limit of integration is infinite. First, I replace infinity by some variable and then take the limit as the variable goes to infinity, in this case. To evaluate the definite integral here, I can use the fundamental theorem because the variable I'm assuming takes on only regular numbers as values. To use the fundamental theorem, I have to do the antiderivative. So I start by finding the antiderivative. For 1 over x squared, so that I can use the power rule, I'm going to write it using negative exponent and then apply the power rule. Negative 2 plus 1 is negative 1, so an antiderivative of x power negative 2 is x power negative 1 over negative 1. I'm going to write the antiderivative using fractions rather than negative exponents, so it's easier to calculate the limits. So I will write the antiderivative as negative 1 over x. The next step is to find the regular type of definite integral, that is what I have here, using the fundamental theorem. So I calculate the net change of the antiderivative from the lower limit of integration to the upper limit, in this case from 1 to r. So substitute the upper limit, substitute the lower limit, and subtract. I'm going to simplify this a little bit before doing the limit. The second term is plus 1, so I get negative 1 over r plus 1. The third step is to actually do the limit. R appears only in the denominator. As r goes to infinity, 1 over r goes to 0. I get 0 plus 1, or just 1. This is the basic approach I will use to calculate improper integrals. We will continue doing a few more examples in the next 3 or 4 sessions.